So now, when you get to the job on the left-hand side, I want you to fill all this stuff out. When you leave the job, I want you to fill it all out again on the other side right here. Okay? So when you get there, I want it filled out on this side. And when you leave, I want it filled out on this side because it's all going to change if you add refrigerant to the system or if you clean the condenser, it's all going to change. Okay? If you clean the blower wheel, clean the condenser, add refrigerant, remove refrigerant, change the dryer, clean the evaporator coil, it's all going to change. Okay? Okay. Let's go ahead and start back on condenser coils, guys. I want to know if the condenser coils are okay, or are they dirty, or are they filthy. Well, if you walk up to a condenser coil, listen to what I'm telling you guys. If you walk up to a condenser coil, and those condenser coils got dirt packed all the way around them, they're filthy. If you walk up to them and they just don't look dirty, you know what? You got to check off dirty because it probably hasn't been cleaned in the last year or two. It's dirty. Unless you know that it was cleaned last week or last month, it's dirty. End of story. You can't always see that the condenser coils are dirty. How many times you walk up to a Goodman unit, you look at it, you can see the fins around it, it rains on it all the time, and you go, that's not dirty. It's on a clean piece of cement. Does it look dirty?
Spray it, it shows.
But once you spray the chemical on it, it turns brown and gray and black coming off of it. So every condenser coil, I'm telling you, is dirty. Ryan, you're going to have an iPad. When you look at the iPad, you're going to be able to look through it and you're going to look at the history. And the history is going to say, hey, this system hasn't been cleaned in 2 years, in 6 months, in 8 years. We haven't been there. This is the first time we've ever been there. You'll be able to see that. And if it's the first time we've ever been there, number one, we've got to make a great impression on the customer, right? Right. And we have to do an entire checklist so when that customer finishes, that customer knows that we did a thorough check on this system. But I'm going to tell you now, every condenser is dirty. The last technician I had last year, every single customer he would go to, he would just put, okay. And I'd say, Sean, why are you not cleaning these condensers? They're not dirty. So I started pulling history up on all these systems. And I'm like, look, we haven't been there in 4 years. Look, we haven't been there in 3 years. Look, we haven't been there in 2 years. How can you tell me the condenser is not dirty? Well, it don't look dirty. Clean it. Clean it. I'm telling you, clean it. You can't get your proper pressures and temperatures unless you clean every condenser you go to. Now, is cleaning the condenser just hitting it with a hose? Is that cleaning the condenser? It'll get a little bit off. The only way you're going to properly clean that condenser, guys, is hitting it with the chemical. Okay? When you hit it with the chemical, then it's going to end up coming off. Okay? So, that, Ryan, I'm going to tell you, is going to be my #1 pet peeve on every service call you go to, and of course every PMA you have to clean. But every service call you go to, ma'am, I need to clean your condenser because you can't get a proper head pressure unless the condenser's clean, right? Right. Okay, well, how can you go any further then, really and truly, when you think about it like that? Yeah. Do you know what your superheat and subcooling are? No, because you don't know what your head pressure is going to be once it's clean. Right. All right, guys, we're going to go ahead and do the next one here. Your condenser fan motor. Condenser fan motor has got 3 deals on here: okay, burned, or loose. So what does that mean? If your fan motor looks like it's in good shape, the paint is still on the fan motor. It's not making a knocking noise or a squealing noise or anything like that. The fan motor should be fine. If it's loose, you can actually turn that fan motor over and you can shake the motor. What I mean by shake the motor is you can grab the fan blade and you can shake the shaft of it, and it'll go back and forth. And if it shakes, that's a loose bearing up inside of that thing, because grab a brand new fan motor out of the box and try to move that shaft. It won't move. But grab an old one and shake it, the bearings are going bad in that motor. Okay? That's no bull. You're telling them straight out that the bearings are loose, and you can shake it and show it. Okay? If it's burned, what I mean by burned is if the paint is burned off of the fan motor. So if you look at the motor and the motor's all rusted, tell me why it would be all rusted.
Burn the paint off the paint on it.
How does it burn the paint off of it?
It's overheating.
Overheating. So what does that tell you? It tells you the condenser has been running hot for a long period of time. And when it runs hot for a long period of time, it starts to overheat that fan motor, and it starts to burn the paint off of it. Once you burn the paint off of it, now it's weathered. Now it starts to rust. So that fan motor tells me the history of that motor. Okay? So now watch this. You go out there and you got a dirty condenser coil. I'm sorry, you have a filthy condenser coil, right? You have a burned fan motor, right? So now here's what's going to happen. You're going to go ahead and clean that condenser, because that's the first thing that you're going to do is clean that condenser, right? Once you clean that condenser, guess what's going to happen to that motor?
Don't go out.
It's going to overheat itself, because the bearings are going to start getting tight inside that fan motor, and it's very possible that fan motor is going to stop because you just changed the temperature of the bearings inside that motor. They have been running so hot for so long with a filthy, dirty condenser, and now you clean it and get that air over that condenser. Now when you do that, boom, now that motor starts to run cool like it's supposed to. Well, it never was running like that, and the bearings are all swole up and everything. Now that motor starts to get tight, and about a week later they call back and they go, "You just cleaned my condenser, now you ruined my fan motor." No ma'am, I cleaned your condenser, and because it was so dirty before, that ruined your fan motor. No, it was working fine before you got here. That's what they're going to tell you. So here's what you tell the customer before you clean that condenser or after you clean the condenser. First of all, do you have to clean the condenser?
Yeah.
You do. Can't get around that, right? So I tell them after I clean the condenser. Is there anything wrong with the motor right now? Right this second? It's running, right? There's nothing wrong with it. So after I clean that filthy, filthy, dirty condenser, and it's all running, I'm having no problems with it. Sometimes when I change the temperature of that fan motor, you can actually hear those bearings a little bit louder. And then now you definitely better tell that customer, hey, those bearings are starting to get a little bit louder, and it's possible that motor's going to give out on you in the next 2 or 3 days. I'm not telling you it's bad right now, because you can go out there and see it spinning. But I don't doubt that you might be calling me back in a few days to replace that motor. If you want, I got one in the truck, I can replace it today. So anytime you clean a filthy, dirty condenser, you have got to tell that customer, after you've cleaned it and you checked everything, you're fixing it, ready to leave, you go, look, I just want to let you know, this could happen. When we clean condensers that are that dirty, it is very possible for the bearings to go out in the motor. Now, it's working right now, so I'm not telling you it's bad right now, and I'm not going to replace it if it's not bad. It's working right now, but I will tell you, you've seen that condenser. I brought you out there and showed you how dirty that thing was, and I showed you how much stuff was coming out of it, right? I just want you to understand, I didn't cause the fan motor to go out. If it goes out on you in the next week or 2 weeks or something, I want to let you know, it's working and there's nothing wrong with it, but because the temperature changes in that motor, it's very possible that fan motor may go out on you. So just to let you know, if it goes out on you, give me a call. I can come back and put a new one in. It's going to be $385, $400 to replace it. But as long as it's working, you're okay. Okay? So that way, if you do call me back, you'll know what's going on. That way, they're not calling you back and blaming you for it. Because they would definitely blame you for it. Okay? Okay, Schrader valves. I got okay or leaking. That's self-explanatory, guys. If you got Schrader valves, and those pins are leaking, what do? You put a new pin in it. You got Schrader valve remover tools that you can pull a new one, pull the old one out, put a new one in, screw it in there, boom, stops leaking. If you don't have another Schrader valve pin, how can you replace that Schrader pin if you don't have that remover tool? Any idea how you can replace it?
Yeah.
How?
Well, you can pump down the unit.
Now, you pump down the system to about 5 pounds of pressure inside the system. Now that you got it down to about 5 pounds of pressure, you get your other Schrader pin ready. You pull that one out, put your finger over it because the pressure is going to push out. Then you take your other pin, put it in there and screw it in there. And because the pressure is blowing out and not sucking in, you're not getting moisture in the line.
Right.
Okay? So it's possible to change a Schrader pin without having the tool, the Schrader valve remover. Okay? Service valve caps. How many times did you go on the service valve cap, the top of the service valve? There's no cap on it. Okay, well we got a whole bunch of them in the room over there. In your toolbox, you should have a few of them, just in case you get to one of those systems. Because I'm telling you, if you go service the system and you turn around and leave and it's leaking 2 weeks later, it's your fault. Did you note on here that the service valve caps are bad? Are missing, absent? Did you note on here that it was doing that? Did you make a recommendation to replace them? No. If the answer is no, you didn't make that recommendation to replace them, it's your fault it's leaking then. Okay? A dryer. Dryer is okay, it's leaking, or it's rusted. Okay? Well, leaking is kind of obvious. You ought to have some oil around it. If it's all rusted, what happens if it's somebody soldered it, melted the paint on it, the paint bubbles up and it starts rusting all around it. Guys, you know why you use thermal paste on the dryers? So you don't burn the paint off of it. How many of the dryers you see where you soldered at, it's all burnt right there. And then it starts to rust right there, right? You know why? Because nobody protected the paint on it. You're not supposed to overheat that paint because the paint then boils and boils the paint up. Now that it gets oxidation inside of it, then the dryer starts to rust. That's why that dryer rusts, because you caused it. Okay? Thermal paste on it, or a wet rag around it, then the paint won't burn, and it won't bubble up, and it won't rust. It may rust in time, but it's not going to rust anytime soon. You caused it. Remember that. Okay? Why do the Schrader pins leak most of the time? Because you didn't put thermal paste on the service valve, or you didn't put a wet rag on the service valve. So when you soldered it, what happens? You heated up the Schrader pin, right? So you don't solder a 7/8 line set without putting thermal paste or without putting a cold rag on that service valve to stop from heating up the service valve. Yeah, make sense, guys? Don't do that. Don't mess up my brand new systems, okay? Understand that? Everybody understand how to do that. Okay? Thermal paste and wet rags around service valves. Dry nitrogen running through the systems with Schrader pins out. Okay? Contactors. Well, first of all, can you replace that dryer if it's rusted and not leaking? Sure you can. If it's all rusted out and it's looking like it's ready to start leaking, why can't you make a recommendation to replace that dryer before it starts leaking? Now when you go resolder it back up, what do you do? Thermal paste. Thermal paste, right? Alright, contactor. Is it okay? Is it pitted or is it welded? Well, how many times you go to a contactor and all the points are all burned up inside of it? Well, you should replace that contactor anytime you see it all burn up. Because what happens, every time the contactor pulls in, it makes a spark. Well, the contacts, as they pull in, they just make a flat connection. Well, as it starts to spark up, those two contactor points get all pitted up inside of there. And now they arc up inside there and they can weld themselves shut. And if they weld themselves shut, then the system's going to continue to run and never shut off. Okay, so anytime you're servicing the system or anytime you're doing a PMA, you need to look at that contactor. So if there's a cover over the contactor points, use your screwdriver and take the cover off and look at the points. It may be burned up all up inside of there. You may not know it. Look inside of it and see if it's all burned up. Then make a recommendation. Sir, here's your contactor that's in your system. Here's a brand new one. You see how this one's all pitted up and burned all up in your points? Your brand new one, how everything's nice and clean and you have good connections on it. I'm going to make a recommendation to replace the contactor because every time this contactor pulls in, it makes a spark and it burns up the points in it. So if you put a new one in, now you get a better contact and that saves the life of your capacitor and also ensures that you get correct voltage on the other side of your contactor so that your fan motor and your compressor run properly as well. Okay? Does that make a good recommendation to replace that contactor if it's still working? Did you lie?
No.
Did you cheat them?
No.
Are you stealing from them?
No.
Don't lie, don't cheat, don't steal. Okay? Wiring on the system. Is the wiring burned or is it miswired? Well, if you get there and the system's running, it's probably not miswired. Probably not. Probably not. But I'm going to tell you what, I just went to a friend of mine's house the other day, had a 2-stage air conditioning system, was installed right after Katrina. 2-stage air conditioning system. It has never worked on second stage. He had a single-stage thermostat. The Y2 was not even hooked up in the condenser. The W2 was never hooked up, so he never had second-stage heat, never had second-stage air conditioning. had a single stage thermostat, and was wondering why he never had a lot of airflow out of his vents, and why his energy bill was always $400.
Because heat strips were constantly running.
No, because he had single stage running all the time.
Right.
So what happens when you have single stage run all the time, the system never shuts off and never really and truly reaches its point where it can shut off. I'm still running a 4-ton compressor, but it's got an unloader in it, and I'm only running 2.5-ton capacity. So while it would cool, it never would cool great because I never would kick in second stage. So that's the first time I went and serviced the system, and I found that the compressor was bad. We had to replace the compressor. We had to replace the circuit board in the system on the outdoor unit. And then when I went to go do all that, and we looked at all the wiring on the system, I called him up and I said, "Dude, do you know that you got a 2-stage air conditioning system?" He goes, "Yeah, I got a 2-stage." I said, "No, you don't. You got a single stage because that's the way it's been wired since day one." He was pissed. So miswired is definitely something you need to look at. Okay? Don't assume because the system is running that it's proper. Never assume that. Never assume it. Okay? Your capacitor. If you have a microfarad tester on your gauge, then what you need to do is you need to take the wires off of the capacitor and you need to measure the microfarads of that capacitor. The microfarads are MFD. So if you got a 440 50 plus 5, you have 50 microfarads and 5 microfarads with 440 volts. You understand that? No? You know what a capacitor is, correct? Okay. Well, you got 3 terminals on the capacitor. Okay? Your 3 terminals on that capacitor. This one here, and this one here. This one over here is your fan. This one here is your common. And this one here is hermetic. Hermetic is going to the start winding on your compressor. Common is going over here to your contactor. Okay? And your fan is going to your fan motor over here for the capacitor. Between common and fan, there's 440 volts. Between common and hermetic, there's 440 volts, which brings 440 volts to your start winding to start that compressor. The 50 microfarads is between here and here. So between this one and this one, it reads 50 MFD. Between this one and this one, your fan, it reads 5 MFD. Now, it may be a 50 plus 10, a 50 plus 7.5, a 50 plus 12.5. Okay? Now, here's another thing. You can have a 440 plus 50. You can have a 370 plus 50. Okay? And if you get to a job and there is a 370 plus 50 microfarad capacitor on that system, you can replace it with a 440 plus 50 microfarad capacitor. But if you get there and there's a 440 50, you cannot replace it with a 370 plus 50. 370 is your volts. 440 is your volts. You can go higher in voltage. The higher the voltage, the lower the amperage. So when you look at the capacitor, you read the tag on it. It may be a 440, 45 plus 5, 440 plus 40, a single capacitor. But a dual capacitor would be 3 terminals on it. And here's something else that you can determine which one of these is which. On your hermetic, you're going to have 3 terminals on it. On your common, you're going to have 4 terminals on it. And on your fan, you're going to have maybe 1 or maybe 2 terminals on it. That's how you can actually look at the capacitor and tell which one's common, hermetic, and fan. Most of the time, it's just 1 on your fan, most of the time. So it's usually 4 on your common, 3 on your hermetic, and 1 on your fan is what it normally is. Okay, but sometimes they got 2 on the fan. All right. If you miswire this thing, and you put your start winding on your common and your hermetic winding over here and that, then you'll short the compressor out. How do you know how the wiring diagram goes? Pick it up, read it, and it's going to tell you purple wire goes to your compressor from start to hermetic. It's going to tell you red wire goes from contactor to the run. Common goes from here to there. It's going to tell you what color wire. So if you ever look at a wiring diagram, not only does it tell you where it goes, but it's going to tell you the color of the wire. So just follow the color of the wire. It's going to tell you exactly where it goes. So you ought to pull up on the internet, on Google, wiring diagram. Learn the wiring diagrams. Okay? You also have got to learn symbols. We will do a class on electricity, on the symbols of everything. Okay? You got to understand the symbols. Okay. So when you read a capacitor, you put your microfarad tester on it. So you have a meter that has MFD on it, or UF. That's going to tell you what microfarads you're reading. So if you put your meter on here and it's reading 42 microfarads and it's supposed to be reading 50, you have a weak capacitor. Then you replace that capacitor. If it's reading 28, you replace it. If it's reading 48, I wouldn't replace it. It's only 2 off. You can stay within 10%. Okay? So capacitor size, and then I want to know what the actual reading is. So if your reading says 42, then you should actually go to that customer and say, here's a price on a new capacitor. Your capacitor is reading 42. Bring the capacitor in there to them, put the meter on it, say, see, 42. See what it says? 50. Can they deny you? Can they tell you that you're lying, cheating, and stealing? No. You put your meter on it and brought it right over there to them. What if there's liquid on top of the capacitor? It's leaking. Okay? It's leaking. What if your terminals are burned on it? You got to replace it, right? You can't just fix the wire and put it back on that burnt terminal. You got to replace it. And you got to fix your wire. If you don't fix the wire is going to burn it right back again. Okay. Max fuse size and actual fuse size. If you go to your condenser and you read the label on the condenser, it's actually going to have a max fuse size and minimum fuse size. So you read the max fuse size on there, and then you go pull your disconnect out, or you look at your breaker and see what size breaker it is. Put your actual fuse size, and then put what is actually in there on there. And if they're different, if the actual fuse size, like in the disconnect that's sitting out there right now that I showed you, we had a 60 amp and a 40 amp in there, am I correct?
Yeah.
But the maximum amperage on that system was a 35, I think it was. It was 35. So we literally could pull those two fuses out, put two 35s in there, would be good. Okay. Okay. I want people to check that, and I want them to find it. And I want them to see that it's the wrong fuse size in there. And I want them to note it on their paperwork. Okay? Fuses, are they okay? Are they discolored? Are they burned? Well, fuses are either good or bad, right? They're either open or they're closed and still good. Well, if they're closed and still good, but yet they're all purple and the paper on it's all charred up, is that fuse really still good? No. It actually is good. It's good because it's still got a connection. So it's either open or it's closed. Okay, if it's closed, the fuse is still good. Now, I want to know if the fuse is discolored or if it's burning. If you look at the copper part of the fuse, we all know what copper color is, right? Well, if that copper color is now a purplish color, then that fuse is burning. Okay? So if you look at that fuse and the copper color is purple, then you write burning on there. If you look at the paper of the fuse and you can literally see that that paper is overheating and frying that paper out and it's getting crispy, that fuse is burning. It's not blowing. Okay? What's the difference between a blown fuse and a burned fuse? A burned fuse overheats. Okay? Because of heat. A blown fuse over amps. So if you got a 30 amp fuse and you draw 60 amps on it, you may blow the fuse. But if you got a 30 amp fuse and you're drawing 28 amps, is it going to blow?
No.
It's not going to blow. You know what it's going to start doing? It's just going to start getting hot. Because the resistance is 30 amps. You're drawing 28 on it. It's going to start getting warm. Now, let's loosen up some of the connections on it. Now it's going to start getting hotter and hotter and hotter and hotter. And finally, you start burning the fuse. But now, let's go loosen everything up. And now let's go start and put a load on that system. And if you don't get a good draw on that system, your amperage goes up. And now you blow the fuse. So there is a difference between a blown fuse and a burnt fuse. So if you ever call me up and you go, man, it keeps blowing fuses, I'm going to say, is it blowing fuses or burning fuses? Because that is a big difference. I'm going to tell you two different things to go look for. Well, as soon as I plug it in, boom, fuse blows. Okay, it's blowing fuses. Well, no, I put the fuse in, it starts, it runs, and about a week or two later, they call me back and the fuse is blown again. It's not overamping probably. It's burning them. Is your fuse discolored? Yeah, it's kind of purple. Okay. Well, pull your tab off of it there, look in the inside and see if your wires are burning inside of it. Tighten everything up. Get your connections on it. If you look at your disconnect box or your pullout, guys, on your pullout, there are 4 little deals like that, right? And you got your little handle, right? If you look at this pullout, and you can literally see the screw holes right here where you can stick your screwdriver on and tighten it, it's bad. It overheated and melted that little plastic inside there. So if you see that, I'm telling you, you got burnt fuses, you got bad disconnect, you got to replace your disconnect. Okay? So your disconnect, is it okay, is it bad, is it burning? Well, we just proved it was burning. I can see the screws in there, right? If you don't go to that disconnect and take the panel off of the disconnect and look to see where those wires are tied into, do you know if that disconnect's bad or not?
No.
Because I tell you what, I've replaced a lot of disconnects because I pulled that one screw off and looked in the inside of it, and the wires were burning on the inside, but the breaker was still good and the fuses were still good. But the wire was burning. If I didn't go check, I would have never found it. You know how many capacitors I've replaced? And I'm going, man, I don't feel like taking all the wires off to check this capacitor. It's way in the back and tucked in this, and it's a pain in the butt. And I go over there, and it's reading 28 microfarads, and I got a 65 capacitor. I go, there you go. I just made some money. Okay? Now they got to replace the capacitor, right? If you're too lazy to go check it, guys, don't be lazy. You never get anywhere being lazy. You know? You only get out of it what you put into it. All right, your electrical whip, wrong size or is it burned? How about if it's hanging off the wall, if the whip is too long, if it's curled up at the end of the condenser, if it's a 1/2-inch whip on a 5-ton system, is it not strapped to the wall? Read more into that. Okay, read more into it. If it's something like that, the whip is extremely too long, then you can write on there, just write over the top of that line, too long. Okay? And now you just made a note for yourself, so when you go into the customer, your whip is too long. It's $30 for me to cut the whip, put it in there correctly, strap it to the wall and all that kind of stuff. Would you like me to go ahead and do it? Yeah, I'd like you to go ahead and do it. Go ahead and take care of it. Okay? Hard start kit. Okay, none, or blown. Well, most of the time, you're not going to see a hard start kit on the system. Most of the time in a general statement. There's a lot of them out there. But probably 75% of the time, you're not going to see one. Okay? Here's how you sell a hard start kit. On a perfectly working system. Now, again, I'm going to tell you, don't lie, don't cheat, don't steal. Okay? I can sell a hard start kit without lying to you, cheating you, or stealing from you. Ryan, I went to your condenser, man, and I was checking your pressures and temperatures and your electrical. One of the things that I do is I check the amperage draw of your system. And I put my amperage mode on hold, and I put it on max. So when I started your system, I brought my meter here to show you. See how it's drawing 115 amps on there? Okay? When your system goes to start, it draws what we call lock rotor amps. And I recorded yours at 115 amps. Now, your run load amps was only 16 amps. So what happens when your compressor starts, it draws a real high amperage on it, and then it comes down to run load amps. I'm going to tell you, and that's normal. Okay, there's nothing wrong with your system. That's normal. But what I'm going to recommend to lower the amperage when it starts, I'm going to recommend what's called a hard start kit. I can put a KS1 hard start kit on it. What it is a potential relay and a start capacitor. And what this thing does basically is it kicks your compressor into gear. It adds another 370 volts to that compressor when it goes to start and pops it in its button, kicks it into gear. So now when your system goes to start, instead of that amperage pegging out to 116 amps, it might only drop to 30 amps. I went ahead and I put one on it just to see what it would draw, and it drew 34 amps when I started instead of 116 amps. Hard start kit is $165. I want to tell you, This is an enhancement to your system. You don't have to have it. Your system's been starting for the last 10 years without it, but this is an enhancement. If you'd like to go ahead and leave the hard start kit on it, it will lower your amperage down when the system goes to start, and it'll make that system easier to start and give it more longevity. Would you like me to leave it on or take it off?
Leave it on.
Okay. Did I lie?
No.
Did I cheat? Did I steal? I gave you the option to make your system a better unit, right? There you go. Your compressor, is it okay? Is it sweating or is it rusted? If your compressor is rusted, that tells you the history of that compressor. How does your compressor get rusted? Nope. Your compressor gets rusted because it's been sweating a lot. That tells me you had a dirty evaporator coil, probably. System's been running and the liquid has been getting into your compressor, causing your compressor to sweat. When it continues to sweat, the sweat ends up causing rust, and then it starts to take all the paint off of it. Now, if you're running low on refrigerant, what does that cause? A hot compressor, okay? Well, you could have a dirty evaporator coil. At one time, you could be low on refrigerant. You probably didn't take care of your system. You probably didn't clean your condenser as well, so your compressor's running hot. Add all those things together. A compressor running real hot because it's low on refrigerant causes the paint to burn on the compressor. A compressor running extremely cold because I'm sucking liquid in the compressor because I got a dirty evaporator coil causes the compressor to sweat, and you got water on the compressor all the time. What happens when you put water on metal all the time? It eventually starts to rust, right? There you go. You got a rusted out compressor. Most of the time, it's got water on it all the time. How many times have you seen a compressor sweat about that much just by the suction line? That's the way it's supposed to be. Put a silver dollar around it, and there's your sweat on that compressor. If you see that whole compressor sweating, then it's sucking in liquid. There's a problem. The problem could be numerous things. I'm not going to get into that. That'll be other videos for low superheat. Okay? Numerous things. So check the video out for low superheat, and that'll tell you all the things that can make that compressor sweat. All right? Compressor amps. You're going to have your run load amps and your lock rotor amps. So what we just did with a hard start kit, guys. I recorded your run load amp 16, and I recorded your lock rotor amps at 116, right? I bring that into you and I say, look, sir, your compressor run load amps is 16, your lock rotor amps is 116. I'm going to recommend putting a hard start kit on your system to lower that amperage down. I'm recording everything for you. This is what we do when we go to a job. I'm going to tell you the performance of your system and what I can do to improve the performance of your system. That's my job when I go to your house. Okay? You got to understand what your job is when you go to the customer's house. It's not just to clean their system and blow the drain lines out and check their pressures. It's to make their system work at 100% capacity. And if you don't check the blower speeds and the coils and the ductwork and the return air and the air leaks and the superheat and the subcooling and the delta T, are you actually checking the entire system? Okay. Time delay. Is it okay? Is it shorted or there's none? Time delays are a lost art in this business, guys. I never see a time delay on a system. What is a time delay for?
Compressor, right?
It's basically stopping the compressor from short cycling, okay? So here's what I want you to do. I want you to run that system right now. And I want 24 volts going to my contactor. And I want the power to go out outside. And when the power goes out, what's going to happen to the contactor? It's going to open up, right? Now, what happens when that power comes right back on half a second later? Boom, comes right back on, and that compressor is running, it stops, and it starts again, right? Well, hey, I got a time delay on my thermostat, so that's going to prevent that. No, it won't. You know why? Because you got a battery-operated thermostat, and the battery is continually holding together the R and the W, the R and the Y, and it's constantly sending voltage out to it. Okay, or it's constantly making that contact, so it's not seeing a short cycle. But if you go to your thermostat and raise it up and bring it down, raise it up and bring it down, it will stop the short cycle. So you can sell a time delay on every system because it is an anti-short cycle device. Anti-short cycle is another word for time delay. If that power goes out, it's going to delay starting again for 5 minutes. All the new systems with variable speed and two-stage, with a circuit board there, it's got a time delay built into it. Okay? All the good systems have a time delay. All the old systems, the good systems from years ago, had a time delay. Today, they don't come with time delays. You know why? Costs a little bit less. That's the reason. Okay? Plus, they have scroll compressors today comparative to the old reciprocating compressors. And the scroll compressors actually can do a better job at starting and stopping real fast comparative to the old reciprocating compressors, where your head pressure and your suction pressure were unequal when it stopped, and it was hard for it to start. That's why with a reciprocating compressor, you always had a hard start kit on the system when it had a TXV, because your pressures remain unequal. With a scroll compressor, your compressor actually equalizes its pressure through the compressor. That's why you'll hear that sound when it goes and stops. That compressor is basically allowing it to run backwards. Now, here's what can happen with a scroll compressor. You turn the system off real quick and turn it right back on, and you hear that compressor go, and it's running and makes a lot of noise when it's running. Okay? It's running backwards. And if you've got gauges on the system, I know what that sound is. And I'll tell you, there was a job right over here in Harvey. I went over to it, and I had to kill the power for just a second to do something. I forgot what I was doing. And then when I went to go put it back on, I heard the noise, and I went, no, I don't think that's it. Well, but it was just, it was bugging me, and I went inside, talked to the customer for a minute, then it walked back out to my truck, got my truck, went to go leave, and I'm like, let me go check. It's just bugging me, Got back out of my truck, went back there to the unit, put my hand over the condenser, it's blowing out cool air. Compressor's running though. Pull the plug on it, let it sit for 3 or 4 or 5 minutes, put it back in, boom, compressor sounded perfect again, started blowing hot air out again. You got to know that sound, guys. If you don't know the sound, and if it sounds weird to you, the compressor could be running backwards.
I know that from 3-phase.
3-phase can run backwards. How do you fix that? You take 2 of the leads and you swap them.
I figured out when I first started doing air conditioning work that happens.
Yep. All right. The condition of the condenser. Okay, fair or poor. Guys, if the condition of that condenser is fair or poor, that is a reason to replace that system to begin with. Because if the condition of the condenser is poor, you're not pulling the heat out of the house. Your capacity on that system is tremendously low. Ryan, remind me later on, and I came across another software program at the dealer meeting this weekend, that we can plug in a bunch of numbers on this program, and you can go on your iPad, and it'll actually give you the capacity and the efficiency and the SEER rating of that particular system, the way it's running right now. If you go to iTunes, iManifold. Rubbertex, tubing size. Tubing size, I want to know what size copper lines you have, because if your model number says a UANL 060 and you got 3/4 3/8 copper, you got a 3/4 3/8 copper line on a 5-ton system, and that's not right. Okay? And I want to know if the copper's strapped to the wall. How many times you see a bad installation job done, and that bad installation job, the copper's hanging all out of the wall? There was a commercial for one of the air conditioning companies, not a local one around here actually, and the copper lines hanging out of the wall on the commercial, guys. Here's the wall. Copper came out like this and went to the condenser. Bad job, man. And it was on a commercial. That was bad. Okay.
Shooting social lines.
All right. So Rubbertex is the condenser. Where your condenser is, are you missing any Rubbertex on that suction line? If you're missing Rubbertex on it, you can sell them $40 to put new Rubbertex on it for that 6 feet up to your line, right? And then retape it all, make it look nice and neat. Why can't you sell that? You can sell it all day long, guys. How about the slab? Is the slab sinking? Or there is no slab? How about it's just a couple bricks holding it up and underneath is the dirt? Why can't you sell a slab, put a slab up underneath it? Why can't you sell cinder blocks in a slab to raise it up because it's sitting in the dirt? And you go, man, what I really need to do is cut these lines, put some cinder blocks, then put a fiberglass slab on top, get it up a foot out of the dirt, resolder up the lines, pull a vacuum on it, charge it up. You're looking at about $350 to do that, but you really need to do this because you're killing the efficiency of your system. Your dog is laying at the condenser, he's kicking all the dirt up inside of it. There's a 1 foot pile of ants inside of your condenser here, and I cleaned it all out, but I'm telling you, next week it's going to be back the same because your dog's kicking all the dirt back into it. He's laying right next to it. Why can't you give them a price to raise that condenser? Isn't that what needs to be done to fix the problem?
Yeah.
Okay, well, what'd they call you out for? They called you out to fix their problems. That is a problem. Give them a price to fix it. They may not want to do it, but you got to give them a price to fix it if that's what you found, right?
Right.
Okay. Go up to the top now, which you got your coil. I want to know if it's R22 or 410A. Then you go to your air leaks. Air leaks are going to be none, small, or major. Well, if you don't go check the duct system and the supply plenum and all that kind of stuff, how are you going to know that? So you got to get up there and go do a little work, don't you? Don't assume. Spell out assume, guys.
Yes, you and me.
Okay. Coil. Is it clean? Is it dirty? Is it clogged? Ryan, tell me how you can tell if that coil is dirty if you can't get to it and see it.
By pressure.
Your pressure
So,
and
superheat.
superheat. What if it's got a TXV?
Can't. Not by superheat.
Then how are you going to tell?
You can tell subcoolant, sorry.
How are you going to tell?
I wouldn't.
How are you going to tell?
Delta T.
Delta T.
Sorry.
And your subcoolant is going to be high, and your suction pressure is going to be low, and your superheat is going to be normal. You're going to have a low head pressure, high subcoolant, low suction pressure, normal superheat, high delta T. Well, you mean I got to go check all that stuff? Yeah, it's part of your paper. This is what you're supposed to be doing. So what is normal? What's your normal delta T? 18 to 20 degrees. What's your normal subcoolant? 10 to 12 degrees. What's your normal superheat? 12 to 15 degrees. Well, go to look at your condenser, and it says, on this particular condenser, I'm making up 85 degrees outside, head pressure, 285 pounds. What is yours? 255. Well, something's wrong. Why is your subcoolant 18? Well, I just let a little bit of refrigerant out, right? If I let a little bit of refrigerant out, my subcoolant's 18, and my superheat's going to stay the same, right? So if I let refrigerant out, bring it down to 12, isn't my superheat going to stay the same? Yes, it will. Because if TXV maintains a constant superheat, right, Ron?
Yeah, always.
Did my suction pressure drop now that I took refrigerant out? So now instead of having a 40-degree coil temperature, I had 35, and now I have 32 because I let refrigerant out, but I maintained my same superheat, right? And my subcoolant came down where it's supposed to be, so the system's working right now. No, you got a 32-degree evaporator coil temperature. Now the system's working worse because you let refrigerant out because you never checked the delta T to return in the supply. You see where I'm at, guys? You can't just go look at one thing. You can't just go say, hey, there you go. Eric told me subcoolant should be 12 degrees. It's 18. I'm letting refrigerant out. I'm getting it to 12. I'm sorry, I'm recovering the refrigerant, and I'm getting it down to 12 degrees. Okay? Well, Eric also told you that your superheat should be about 15. It is. Eric also told you that an ideal coil temperature is 40 degrees, and you're reading 35. It's low. And you let refrigerant out, you're going to drop your suction pressure. You're going to drop your head pressure. Well, if you looked at your condenser, your head pressure is already low. Now you let refrigerant out. No, stop. Don't touch things when you don't know what you're supposed to be doing. Okay? If you don't understand it, don't touch it. Go to school. Come to class. I'll teach you. Coil. Clean, dirty, and clogged. A lot of coils are dirty, guys. Ryan, you want me to tell you to spend $100 and you can make that $100 tenfold? They got a snake with a little camera on it.
Rigid.
Rigid. $89 to $99.
You can hook it up to your phone.
It's a little snake, huh?
You can hook it up to your phone.
Yeah, it's got a little camera. It's got a little.
They got the ones you can hook up to your phone.
It's got a little camera on it. You stick the little thing up inside there, boom, you can look at your evaporator coil. So here you go. Look, you got a vertical system. Watch this. You got a vertical system heater, right? You got a coil sitting on top of it. There's your A coil, right? Well, your chambers are like this, aren't they? Up inside here, right? Where's your limit switch? Right there, right? 2 screws. Boom, boom. Take your limit switch out. Now you got a hole in your chamber, right? Stick your snake right up in there and look at your coil.
That's worth its weight in gold.
Guys, I'm telling you, I bought my guys a snake last year. 2 of my guys a snake. I bought it for them to use, and they never used it, so I wasted $200. I figured if you just went and found one dirty coil, I would make my money, and I'm okay. The rest of the year is on me. Big deal, okay? So what? For $100, you can find a coil all day long.
The time it'll save.
All day long you can find it. Okay? If they got one you can hook up to your phone and it's in color, well, you know what else you could do? I'll tell you this. If you can actually hook that thing up to your phone and do a screenshot and it gives you color, how about if you drilled a hole inside your supply plenum and you stuck it in there and took pictures inside your supply plenum? All the mold and mildew up inside your supply plenum. Guys, it's easy to do that. You know what you got to do? Let's say you got a horizontal coil, okay? You go to the end of your coil, which is where your cap is at, right? How hard is it to take one little piece off of your cap and stick your hand up in there with your phone and take a couple pictures up inside there? All day long you can sell supply plenums. I'm telling you, there's nothing but mold and mildew inside of a supply plenum, right? Ryan, I'm going to your house and you got 2 little kids and a wife. And I go, Ryan, I went ahead and checked your supply plenum. And your ductwork up there, your system's working fine. Your pressures, your temperatures, your electrical, everything's working fine. But while I was up there, I went ahead and I checked your ductwork. And I looked at your supply plenum, and I pulled the cap off of it, and I took some pictures of your supply plenum and the inside of it. Because a lot of times we build a lot of mold and mildew up inside these systems. And I don't know if this is of any interest to you whatsoever, but here are the pictures that I took inside your supply plenum. You see all that mold growth up inside that system? Did you want me to take care of this, or did you want to leave that in your house? Give me your answer.
Take it out.
Okay. Well, here's your price, Ryan. It's $600 for me to replace that supply plenum. And for $75 more, I can treat that plenum with a chemical called Foster's 4020, which is an antibacterial paint that helps stop mold growth inside of your system. And that will actually make that air inside your house a lot cleaner and help stop mold growth inside there. But I tell you what, I see you got 2 little babies here, and if you really want me to clean the air in your house and stop all this stuff from growing inside here, what I really need to do, Ron, is I really need to put a UV light inside your supply plenum. And I tell you what, your supply plenum is dark, damp, and cold up inside there. And a dark, damp, cold place always grows mold. There's nothing I can do to always just prevent mold from growing unless I make the surface area of your supply plenum non-conducive for mold growth, which is the Foster's 4020 I was telling you about. And then if I put a UV light inside that supply plenum, those UV rays will shine up inside there, and they will help prevent the mold growth up inside that supply plenum. Is that something you would like to do as well? The UV lights are $550. So you're looking at about $1,250 total to do the whole 9 yards. We can schedule it probably next Tuesday if that's what you'd like.
Yep, let's do it.
Okay. Did I lie? Did I cheat? Did I steal?
Yep.
I told you the God's honest truth. I didn't stretch the truth. I didn't tell you a little bit and keep adding these, I'm telling you the truth. And I got the pictures to back it up.
Right.
So you see, Ron, all these things I'm telling you, how to do them, I've done them for 21 years now, 24 years. I've done them. And I've made a lot of money. So if you do this when you go into these service calls, you learn how to make money. There's a difference between learning how to fix a system and learning how to make money.
Right.
You can take a service tech all day long, fixing things all day long, and you don't make any money.
No run.
But when he goes above and beyond fixing the unit that's broken, changing the capacitor, leaving, and you go out there, you change the capacitor, you clean the condenser, you check your pressures, temperatures, electrical amperage, hard start kit, time delay, surge protector, supply plenum, ductwork, air leakage, drain lines, float switches, and you go check that whole 9 yards of the system, you can walk away with money and never, ever tell a lie when you go out there, never screw a customer. There's too much money to be made
To do that.
to do it, you know, with no morals. I mean, there's too much money to do it properly. You know, just do the right job. That's all you got to do. All right, refrigerant leaks. None visible or undetectable. Well, how do you know if you got refrigerant leaks in your system, guys? Well, if you go out there and you put your gauges on your system and your system's low on refrigerant, guess what? Not necessarily. Because how do you know if it was charged up properly to begin with? What if your subcooling is 4? After you cleaned it and everything's working fine and your subcooling's 4. He's never had a problem with the cooling, but your subcooling is 4. Does that mean he has a leak in the system?
Not necessarily.
No, it really doesn't. You know what it could mean? Whoever charged the system up went beer can cold. That's no joke. Okay? So, and the sight glass cleared at 4 degrees. Okay? But it's still not charged properly because the condenser tells you what head pressure to bring it to. That particular condenser may be a 6, 8, 10, 12 degree subcooling on it, okay? So if you know what it's supposed to be, and you're reading 4, and it's supposed to be 10, then go to the customer and say, you're a little bit low on refrigerant. But I'm going to tell you, I know your system's been cooling fine, everything else looks good, but you're 6 degrees low on your subcooling. So I'm going to recommend go ahead and charge the system up, put that extra refrigerant in. I really don't think you have a leak in the system. Let me ask you, have you had to put refrigerant in this system? I see it's about 8 years old. Have you ever had to put refrigerant in the system? And the guy goes, no. I don't think it's low on refrigerant, meaning you have a leak. You possibly could have a slow leak, though, okay? Because this is the first time I've been here, okay? You possibly could have a slow leak, but what I would do is let's just go ahead and charge the system up this year. When I come back next year, I'll have all documentation showing what I read last year, and if you're low again next year, then we know you got a little small leak. But let's just go ahead and add a little bit this year, and we'll be good to go. Don't go scare them and tell them all kinds of other stuff. And
Right.
you know, if the system's really low on refrigerant, okay, scare them, tell them the truth. R22's phasing out. Here's where you're going to be at. Use a judgment call on that, okay? So, refrigerant leaks, none, visible, undetectable. Okay, you write your head pressure, your suction pressure down, your superheat down, your subcooling down, and you put on there refrigerant leaks, none. And you got down at the bottom here, R22, $180. Wait, you told me refrigerant leaks, none.
You put undetectable.
Undetectable. Did you recommend a leak search? Did you say anything about it? You know what you're going to do in this column, in this area right here? System running 4 degree subcooling. Added 2 pounds of refrigerant, pound of refrigerant, whatever it is, brought subcooling to 12 degrees. That should show up here as well, which you're going to have when you got there and when you left. That should show that as well. But you should have something on there stating why you added a little bit of refrigerant and is it undetectable and not visible. Okay? Because if you added a lot of refrigerant into this system, then you need a price on a leak search. Okay? Now, a leak search can run anywhere from $90, meaning labor to run a leak detector around the system, okay, to $550 to do a pressure test on the system. System's really low on refrigerant, don't you need to find out where the leak is at?
Yes, sir.
Did you find and fix the problem? Or did you make a recommendation? Because let me tell you what the customer's going to tell me. You go out today, you put refrigerant in the system. 3 months from now, system's low on refrigerant again. I read your invoice, and your invoice says, found system low on refrigerant, customer wanted system charged with refrigerant, service fee, refrigerant cost, boom, done, over with. Customer calls back 3 months from now and goes, your guy was out here, he put refrigerant in the system, I shouldn't have to pay you to put more refrigerant in the system. And I go, yes ma'am, you should, because refrigerant has no warranty. Well, your guy didn't fix the leak. Well, you didn't pay for the leak fix. Well, he didn't tell me where the leak was at. Well, you didn't pay for him to do a leak search. Oh, wait a minute. He didn't even recommend that we do a leak search. Now whose fault is it? Okay? Can I give her money back for refrigerant? Can I go add refrigerant in for nothing? No. Can't. But you know what? Yes, ma'am. I see that he didn't make a recommendation to do a leak search, but he did add refrigerant to the system. There is no warranty on refrigerant. It says so right here that there is no warranty on refrigerant. Now, tell you what I'll do is I'll go back out there. We won't charge a service fee to go back out there, but if you want more refrigerant in the system, I'm going to have to put more refrigerant in, but there will be a cost on the refrigerant. I'll save you money on the service charge. But now, if I put refrigerant in the system 3 months from now, you're going to call me again and say it's low again. Do you want me to fix your problem, or do you want me to postpone it until a later time? Now, what I can do, ma'am, if you are interested, if you want to fix your problem, the $180 that we put in refrigerant, I can look at that maybe and put some of that towards a replacement system, a replacement coil, if your system's old. Would you like to maybe look at that? Because how many times have you had to put refrigerant in your system over the last 3 years? Well, about every year I got to put refrigerant in. Well, I don't know who's been doing it. We may have even been putting refrigerant in for the last 3 or 4 years. And the customer may be saying, no, just add for refrigerant, just put refrigerant, just put refrigerant. Well, now it's $280 to put refrigerant. Last year was $180. Next year it's $480. The customers go, you're just screwing me. No, we're not. R22 is $480 a drum right now.
It's going up.
Okay? It ain't cheap. And it's going to keep going up. Ma'am, would you like me to fix your problem? If you want me to fix your problem, we need to find your leak and then repair your leak or replace whatever part is leaking. If you'd like me to do a pressure test on the system, you're looking at $550 to do a pressure test on the system. I will isolate your condenser, your line set, and your evaporator coil. We let it sit for a day or two. We come back later and we find out where your pressure is leaking from. If it's in your evaporator coil, I will have to replace your evaporator coil, which will end up costing you about $1,600, $1,800. If you're going to spend $1,600, $1,800 to replace that evaporator coil, I'm going to recommend you replace your condenser as well, because you do have an R22 system and your system is 12 years old. Now, we can put $400, $500 into a leak search, $1,800 into a replacement coil, or you may want to just take all that money and possibly look into just replacing the condenser and coil, or you can just keep postponing your problem to a later time. Those are your options. They're not good options, but they are your options. What would you like me to do, ma'am? Would you like me to come out and put refrigerant in your system again, or would you like me to give you a price on a replacement system? Did I make my point?
Yeah.
Okay? But if you don't give that customer a price to replace that system, to repair that leak, then you're not doing that customer the right job. You're not doing them proper service. If it was your grandmother and you can't get over there, what would you want them to tell your grandmother? You want them to just put refrigerant in and leave and never say a word? Or would you want them to give them the option? Well, stop doing something or don't do something that you wouldn't want somebody to do to your grandma. Make sense? All right, I want to know if your coil pan is okay or is it clogged or rusted. Sometimes you got a vertical system and that coil pan is all rusted and clogged up. Sometimes on a horizontal system, you can open upside that system and see it all clogged and gook all up inside there, especially if you got a dirty evaporator coil. Okay? I want to know if you got a TXV or a piston, and I want to know if it's okay restricted or not insulated, or if it's the wrong size piston, or if it's restricted. Now, how are you going to know that? Head pressure, suction pressure, superheat, subcoolant, right? That's going to tell me whether you got the proper TXV, whether your piston's the right size, whether it's restricted, whether it's open, wide open. You got to know, you got to understand what your head pressure, suction pressure, superheat, and subcooling mean. If you do not know what all that stuff means, go to the other tapes that we have that explain low superheat, high subcooling, high head pressure, low head pressure, low this, high that. It explains all that. We have other tapes that go through in detail about that. You guys are going to have your usernames and passwords on Linux DaveNet, and the first ones you need to go to are Refrigeration 101, the maintenance series. And start with number 1 and go through number 5. And the first one gives you the refrigeration cycle and how it actually works. You don't understand that. It's like turning a light bulb on and don't understand how it gets bright. I don't know, it just gets bright. And if you're happy with that and not knowing how that little thing works inside there, then fine. Well, don't expect to charge my systems up if you don't understand it. Make sense? You can keep turning the light bulb on and nobody's going to fault you for that, but you're not charging my systems unless you understand superheat and subcooling. Okay? Fair enough? All right. Return plenum and supply plenum. I want to know if it's okay, if it's restricted, if your return plenum is restricted, if it's leaking air, if your supply plenum is sealed or your return plenum is sealed, if it's leaking or if it's falling apart. Well, on your return plenum, guys, you get a lot of restrictions on your return plenum because people just do not install the systems properly. A lot of times. And when you go there, especially on a service call, on an install, we're going to replace it, so we better install it properly, right? We better make sure that the holes are cut out big enough so that you get the proper airflow through the system, okay? But on a service call, you're going to everybody else's, okay? Let's make sure we do the right job by looking from the return grill all the way to the back of the heater. Your return is from the back end of the heater to the return grill and anywhere in between that chase. That is your return plenum. Okay? If you stick your head inside there and you look up and you don't see the same size up top as you do below, it's restricted. Okay? Look at the transitions. Look to see how the transition's built. Sometimes you'll see a transition start here at the heater and it comes down like this. And then it comes from here and it goes like this and you go, wait, it was this big at the heater, and then it comes back down to this, and it's real small. Well, somebody just expects all that airflow to get through that little hole. Somebody needs to get some common sense. Can't get all that airflow through there, guys. Okay? All right, air leaks. Return air leaks and supply air leaks. Guys, if you got a return plenum in the attic, go pull the insulation away from that top plate all the way around it. Go look to see that at that top plate, where the 2x4 is or the 2x6 is, and that metal goes right like this. Well, here's your air leak right there. That's because that plenum goes like that. And nobody ran foam around it. Nobody sealed it. Or how about this? Where that 2x4 comes down to the bottom here, okay? And your sheetrock is right here, it don't reach the sheetrock because there's a 2x6 right here, and there's a 2x4 right here, and you got 1.5 inches left over before you hit the sheetrock, and because the insulation's laying there, it blocks it and you can't see it. Oh, now you got to look inside there because in between your sheetrock and your 2x4 is that big of a gap that sucks air right into your attic. And the only thing stopping it from sucking air in is fiberglass filter, right? Which is your insulation. You got to move the stuff out the way, guys. And actually stick your hand around there and feel it, okay? Look at it, okay? Don't assume it's correct because it's probably not. All right, I want to know the duct insulation. If you got hard pipe duct, watch how this works, guys. Okay? Hard pipe duct. What happens when you have hard pipe duct through the years? What happens to the insulation, guys? There's the inside of it, right? So Here is the insulation around your ductwork, literally, right? 1/4 of an inch. Okay? When it was originally installed, it was R4 value insulation on that duct, which was 1 inch. Okay? That was original. There it is today. R4 is 1 inch. What's a 1/4 inch? R1. Okay, R2, max. I've got a sheet of paper that shows you the actual heat load on a duct. Think about this, guys. It's 130 degrees right here in your attic. It's 50 degrees inside your duct, right? So this is R4. This is going to be R1. So here's R6. Here's R8. 130 degrees inside your attic. Trying to get through and cool off your duct, right? Or heat up your duct, right? Okay? So the thicker your insulation, the less you have to cool your ductwork. How many BTUs on a 1,500 square foot house? 3-ton system, right? How many BTUs does it take to cool your ductwork? Not your home, your ductwork. Don't you have to cool your duct before you cool your house?
Right.
So let's turn the air conditioning system off for 2 hours and it's 3 o'clock in the afternoon. What temperature is your ductwork now?
Probably 130.
It's 130 degrees. So that's why when you turn your air conditioning system on, what happens to the airflow when it blows out? It's hot.
It's going to be hot first.
So you just put BTU and heat inside of your home, right? So what you have to do now is you have to cool your duct and then you can start cooling your home.
Same concept as your water hose when it's hot outside.
Yeah, you gotta let the air out, let the water out, right? Okay. Here are some true numbers. They're not exact, but they're close, okay? On a 1,500 square foot house, it takes approximately 14,000 BTUs, approximately 14,000 BTUs to cool your ductwork. How many BTUs is 14,000 BTUs in tonnage? 1 ton of air is 12,000 BTUs, right? So I'm using over 1 ton of air conditioning to cool my ductwork and 2 tons to cool my house. So let me ask you, if that ductwork was in a conditioned space, meaning a foamed attic where the attic is cool, how many BTUs does it take to cool the ductwork now? 0. Because it's not in an unconditioned space. That's why you can put a smaller air conditioning system in a foam house. Because the ductwork is in a conditioned space, not an unconditioned space. Make sense? So now watch. Here's what's going to happen. I got R1 ductwork. 14,000 BTUs to cool my ductwork. Let's go ahead and let's re-insulate your ductwork, sir. And if I re-insulate your ductwork, I'm going to go ahead and I'm going to put R8 value ductwork on that. I'm going to just re-wrap everything, just like y'all did the other day, right? Okay? I'm going to cut the amount of BTUs it takes to cool your ductwork down to about 3,000 BTUs. It's still going to take some BTUs to cool it. Okay? But I'm going to cut it down to 3,000. I just saved you 11,000 BTUs, right? I saved you almost a ton of air conditioning by re-insulating your ductwork. Is that something? How about this? Attic, insulation in the attic. Here's your home, 75 degrees inside your home, 130 degrees here, right? We're going to call this 3.5 inches, R13. 1,500 square foot house. I'm going to put a BTU capacity. I'm making these numbers up, guys, okay? I'm going to put a BTU capacity on the insulation here of 9,000 BTUs, okay? So now, if I go from R13 to R30 in your attic, so from 3.5 inches to 10 inches of insulation, I'm going to knock it down from 9,000 to somewhere in the neighborhood of about 3,000 to 3,500 BTUs. Maybe 4,000. Okay? So I may save another 4 to 5,000 BTUs on insulating your attic from an R13 to an R30. Because I added another 6-7 inches of insulation in your attic. So if I did that, I saved, let's call it 4,000 here, and let's call this 9,000. Okay? Let's just call this 9,000 and this 4,000. I saved 13,000 BTUs by insulating your ductwork in your house. Now your house doesn't need 3 tons of air, does it? I just saved it. You know what the customer's telling you when you're going to replace the system? Can you put a 4-ton in? Tell me why they want a 4-ton in their house. Because I'm throwing a ton of air conditioning out. How about if I put a 3-ton back in your house, man, and I insulate your ductwork, and I insulate your attic, and I put a 2-stage system in, and therefore 85% of the time I'm going to cool your whole house on a 1 3/4. Oh, my house never gets cooled. Of course it doesn't. Of course it doesn't. Let's go ahead and let's drop your heat load in your house. What makes more sense? Put more tonnage in your house to cool it, or drop the heat load in your house so that it costs less to cool your house? Which one makes more sense to you? It ain't never going to cool my house. I'll tell you what, if it don't cool your house, I'll pull that 3-ton system out and I'll put your bigger system in for free. How about that? But you got to insulate your attic properly. You got to let me do the job, and you got to insulate your ductwork properly, and let me put a new 3-ton system in. And I will guarantee you this house is going to cool beautiful. Okay? Make sense? All right, I want to know your duct type. Is it hard pipe, flex duct, or duct board? Well, we went over that. Why we're going to worry about hard pipe, right? Now let me ask you, how many systems out there got hard pipe on it? How many of them got 30-year-old hard pipe that you can make that sale on?
A lot.
Are you lying to them? Are you giving them good information? Are you spending their money properly and wisely? Forbes magazine actually rates making your home more efficient one of the top 10 investments. Top 10 investments. Making your home more efficient. Okay, well, what is an investment, guys? Think about it.
Yeah.
I'm going to put money into a mutual fund. If I get 10% return on my money, that's pretty darn good. Well, what if it cost me $3,000 to re-insulate my attic and my ductwork? $3,000. 10% is $300. Do you think you can save that customer $300 in their energy bill next year by doing just that? $300 in their energy bill? Of course you will.
And it's going to continue to happen year after year.
Year after year after year after year, you spend $3,000 and you are going to continue to get more than a 10% return on your money. Is that a good investment?
Yeah.
It's a great investment. Okay? Well, let's go spend another $10,000. Okay? And let's put a new 18-SEER system in, 20-SEER system in, and you're going to spend $10,000. Now you spend $13,000. That 3-ton system in that old house, and they're getting $400 energy bills, and now they're getting $80 energy bills, and I save them a total of, I'm going to call it $2,500. And they spent $13,000. If you do the math on it, 2,500 divided by 10,000, that gives you a percentage of it. I don't know. It's probably going to be in the neighborhood of about 18%. I will take 18% return on my money all day long and be multi-millionaire if I can get 18% guaranteed. Okay? Your home is an investment. Don't think about your air conditioning system as an expense. That's what people do. That's why you can't sell more than a 14-SEER system, because you sell that system as an expense. Ma'am, I know that $5,000 is a lot of money. I know. Boy, I tell you what, if I had to spend that $5,000, it would just kill me. Boy, every time it seems like something breaks and we got to keep spending money, and I understand. I tell you, having these expenses just one after another just kill us. They break us. Yeah. Well, if you're going to explain it like that, you know what? It's an expense. It's an expense. You know, your car broke down and you need a new brake job. That's an expense. Replacing your air conditioning system in your home is an investment. Because when you replace the air conditioning system, it cost you money, but did you save some money? Did it lower your energy bill? If it lowered your energy bill and you're getting money back, it's an investment. It's not an expense. An expense is taking money and throw it out of the window and you have to purchase something. That's not a new air conditioner. It's an investment in your home. Okay? So we're going to a home that is a $400,000 home, and the guy goes, yeah, I need an air conditioning system in. Just put the cheapest one in. That's fine. No big deal. Sir, let me explain these different systems to you, okay? Well, I'm fixing to sell my house anyway, so it's no big deal. Well, I tell you what here. If I'm coming to buy your house and I'm going to spend $500,000 on your home, sir, personally, I want a system that's going to give me a low energy bill. You got a really nice home, and I'm going to ask you what your energy bill is. So if your energy bill is low, it's going to make me want to buy the house more. If your energy bill is higher, it's not going to want me to do as much. So a two-stage air conditioning system, a person buying your home is going to look for quality. So we can do a two-stage air conditioning system on a 16-SEER system, and if you're selling your house for $480,000, $500,000, and that 16-SEER system costs $2,500 more than the 14-SEER system, let's just say that's the case. Do you think that extra $2,500 on a $480,000 house is going to make or break anybody in what you're going to give? Because you know what? You're going to have a bottom line of what you're going to accept for your house, and let's just say it's $480,000. Do you think it really makes a difference if it's $483,000? It really doesn't. It's nothing. It really is nothing. So can I make a strong recommendation to you? Whether you're selling your house or you plan on keeping your house, and you said you plan on keeping it for the next 2 or 3 years, spend the money on the better system, get the quality air conditioning in your home, live here for the next 2 or 3 years with a very comfortable home. Now when you sell it, use your energy bill as a selling point, and your home will sell quicker with a lower energy bill, and when it's nice and comfortable when the people come in, it's going to make a better selling point in your home because you didn't put the cheapest unit in. That's a selling point. That's a sales technique, guys. Okay? I've done it over and over and over and over and over. And does it make sense to you?
Yeah.
If it makes sense to you, can you sell it?
Yeah.
If that did not make any sense to you, because you went, look, I'm going to sell this house and I'm just going to put the cheapest price on it, and whoever buys it, it's their problem. It don't make any sense to that guy.
Right.
Okay? But most of the time, that guy living in a $500,000 home, you can talk some common sense into him. And if it makes common sense, $2,500 is nothing to him. It may be something, but it's not make or break.
Big deal.
Okay? It's not make or break. Plus, he plans on being there for the next 2 or 3 years. And his wife's going, we ain't leaving. I'm staying here. He's selling to her. She's going to buy it. Duct connections, guys. I want to know if your duct connections are okay, if they're leaking or they're broken. Go run your hands around the collars. Go run your hands around the collars and let's see if the collars are leaking air. So go feel if it's cold air or not coming out of the system, okay? Float switches. I need to know if you have any float switches on your system or if they're broken, if the connections are making. Most of the time, you got to just look at the system and see that the float switch is there and if it's actually hooked up. A lot of times I see a float switch there, but it's actually not even hooked up. Make sure they're wired in correctly, guys. Okay? If it doesn't have a float switch on your system, how do you sell it? Ma'am, I checked your system out. Everything's working fine on your system. Can I make a suggestion to you? You got a vertical system in your hallway right here. And I noticed that the wood on your platform has got a little bit rotten through the years. And the reason it's got a little bit rotten is because you've had some water on it. I'm sure you've probably had some water issues with drains backing up in your system. Am I correct? Yeah, that's happened to me a few times. Can I make a strong suggestion to you? Let's put a float switch on your drain line, so if ever your drain backs up, it kicks up a float switch and shuts your system off. And that way I can protect your wood floors. I see you just put new carpet in or new wood floors in, and I would really like to make sure that we protect these things by putting a safety switch in there that will kick up and shut your system off. And that makes a lot of sense because I tell you what, it's only $140 for the float switch, whereas new floors are going to cost you thousands of dollars. This is an insurance policy, basically, is what you're doing for the, by putting a float switch in. I got one in the truck. Would you like me to go ahead and do it? Okay. Drain lines, okay, uphill or leaking. Drain lines, guys, you got to look in that attic. And if you got a 30-year-old system sitting in that attic, or you see that drain line's been there for 30 years, or the house is 40 years old. If the house is 40 years old, how old is the drain line? 40 years? Okay, because it was put in when the house was built. Okay? If the drain line is that old, and the system's 20 years old, tell me how many times anybody has ever, in that last 40 years, ever cut that line and put a cap on it, and cut it over here and put a cap on it, and took that line outside the house and got all the gook out of the line. Tell me how many times in the last 40 years that has ever happened.
Never.
Never, 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 never. Okay? So why wouldn't we recommend that to the customer? Alright? You want to make money? You want to know how to make money? Open your mouth. Look at things like this. This is how you make money. Okay? So when I'm running service, okay, I'm going to get rid of all you guys right now. Everybody's gone. And I get one service call today. Guess what I'm doing? I'm going to make money. Okay? I get one service call today, and I am going to find a way to make money. I ain't going to lie, I ain't going to cheat, I ain't going to steal. But I can find all these different ways that I can make money because I can re-insulate your ductwork, right? I can go take a picture inside your supply plenum and go put your new plenum on. I ain't got nothing else to do today. This is my one service call today, right? So, yes, sir, I can put your new supply plenum on. I'll go get one from the shop, and I'll come back and I'll put it on. I got nothing to do today. It's going to take me all day long, but I made $600 today. Who else makes $600 in one day doing it? Okay? I got no other calls today. Hell, I'll make $600 today. I got no problem with it. It's just going to take me time, right? The plenum might have cost me $40. See where I'm at?
Yeah.
Okay? I can make money without having a whole bunch of employees. I know how to make money. I want to teach you how to make money. So if I can teach you how to make money, guys, then you make money and I make what's left over. And I don't have to go do the work. So Ryan, if you sell that plenum, Gary's got something to go do today. Ann's got something to do today. You sell strapping up all the ductwork, hell, Boo and Jared got something to do today. You got a new plenum we can go install? Well, this guy's got something to do today. You got new drain lines that need to be run? Well, hell, this guy's got something you can do after. Other than that, they're all going home because you didn't want to go look at anything. See where I'm at? Okay. Isn't this common sense?
Very much.
Common sense, guys. Okay. You drain pans and you drain lines. We just went over the drain lines. You drain pans. Look at your drain pans and see if they're all rusted. Why can't we sell a new drain pan that isn't rusted? And why can't we just go to Home Depot or AutoZone and buy a can of undercoating? Why can't we take the existing pan, carry a thing of undercoating in our truck if we wanted to, scrape out the pan, use a wire brush or whatever, okay, scrape as much of it out as you can or whatever may be the case, if it's not that bad and it's just kind of coated with rust. And why can't you just spray undercoating all inside that pan to stop it from rusting? Charge them $50 to do it. Why can't you do that? Okay, undercoating costs me $12 or whatever it may be. I don't know how much it is. $12. Okay, so I charge $60. How long does it take me to spray a pan? 5 minutes. I made $50. I can make money today, guys. I know how to make money. Okay, this is how you make money. You look at everything and you find the solution for every little problem, no matter how little it is. You find the solution for it. Ma'am, your drain line is not insulated. By code today, your drain line is supposed to be insulated all the way to your P trap. I've got the rubber tex at the shop. I can go get it, and I can bring your system up to code by insulating your drain line. Did I lie? Yeah. What did insulating the drain line do for her? It stopped it from dripping on the ceiling, didn't it? It stopped the squirrels from going up there and chewing into the PVC pipe and causing water leaks on the ceiling. I've been in attics where squirrels have chewed bunches of holes in that PVC pipe, and all the way down the house, they had about 8 holes that squirrels have chewed in it, and it dropped the ceiling in about 5 different places, straight down the one run in the house. You could just tell, and it was just dripping. And he didn't know what it was, so I went up there, and sure enough, either rat holes or squirrel holes in the PVC pipe. Rub-A-Tex it, now they don't have sweat on it, so they're not going to look for it. They get in the attic, they're going to look for water. And they're going to keep licking that pipe. They keep licking the pipe and get water off of it. Well, hell, there's got to be something in the inside of it, right? And they'll chew right on through it. Now you got water all in the ceiling. I've seen it a bunch of times. The platform, guys, peat trap and Rub-A-Tex. You need a peat trap on every system. It's supposed to have a peat trap. Go follow the drain line, and you're going to find a lot of times that 3/4 inch drain line runs into an 1.5 inch stack, and there is no reducer on it. It's just sticking in the stack somewhere. Go find the end of it and verify that it's installed properly. If not, if that stack backs up, where's water go? On your ceiling, okay, or on your floor. A lot of times you look inside the return area, drain line comes down, the pipe is just stuck in a big pipe. If that pipe backs up, where's it go? On the floors. Okay. Guys, if you see it's not done right, sell it to do it right. That's it. Rub-A-Tex needs to be finished all the way to your peat trap. Is it not finished or is it missing? That Rub-A-Tex right there is for your coil. How many times you go up to a vertical coil or a horizontal coil and it's missing Rub-A-Tex about 8 inches? And it keeps dripping down right onto the top of your furnace, and it causes the top of your furnace to rust out because it's constantly wet because they got this much copper line with no Rub-A-Tex on it. Charge them to Rub-A-Tex that line and seal it, and the air leaks all around it, seal all that out. Just charge them to do it, give them a price on it. If they say no, fine. Put it on your recommendation, seal air leaks. And then tell them if I got to come back to do it, it's an additional $65. Okay? So when you give them the price of $45 to do it, and they go, I don't know, can you come back at a later time? Yes, ma'am, I can, but it'll be $110 to come back at a later time. Whoa, you told me $45. That's if I do it right now. If I come back, there'd be a service fee to come back. So it's $110. So on your recommendation, you write, seal the air leaks, $110. Because that added your service fee in there. Okay? Platform. Oh, that's extremely important. Then we go over this morning with your platform, how extremely, extremely, extremely important this platform is. If you got a horizontal system and that platform is not level, then that system is off. It's leaning backwards. Coil's not draining properly. If you got a vertical system and that platform's rotting out and it's bowed down and the system's about ready to fall through, okay? Guys, you got to know how to install a platform properly and seal that platform properly and level that platform properly and make that platform big enough, like we said, so it can take your heater and your coil on a horizontal platform, right? We used to just make a platform big enough just for the heater, and therefore the coil would kind of hang out over. I don't want to do that anymore. Okay? We used to do it like that. Now we build a platform as big as the heater and coil so that everything can stand. Okay? Catwalk. I need a catwalk everywhere, right? Both sides of the system, where your ductwork is, the whole 9 yards of it. I want to be able to redo this system and be able to stand on a catwalk to redo all the ductwork, right? So when you're going in the attic for a service call, and there is no catwalk over to the system, can you sell a catwalk? Sure you can. Why can't you? How much you going to charge them? You got to figure $180 an hour for labor. You got to figure your time it's going to take to go do that, and you got to figure you're going to take a helper over there. So you're going to figure $25 an hour, $30 an hour for a helper, okay? And now you can go, okay, it's going to take me 2.5 hours. Figure out how much it's going to cost now. What's your material going to cost? You want me to do it? It's $390. I can go do it. By code, you're supposed to have a catwalk. Okay. Attic stairs. There's a return air grill right here, guys, in the hallway. There's your return grill. Here's your attic stairs. Right? That attic stairs hangs down 1/2 inch. Guess what's happening in that return grill?
Sucking that air.
You're sucking air right into that return grill. All the way around it, right? It's sucking air and it's going right into your return grill. So attic stairs on your sheet here says, okay, leaking, and then covered. What if your attic staircase is in your garage? It's okay. What if your attic staircase is in your hallway? It's either going to be leaking or covered. One of the two. It's not okay. It's in your hallway and it's not covered. It's leaking. Can you ever put up an attic staircase and it don't leak? Is that possible? No. The answer is no. Okay? And here's why. It's not 100% sealed. It's not airtight. It's going to leak. Okay? Now you got a 24 by 54 inch spot that doesn't have any insulation on it either, right? So if I shoot a infrared camera on it, it's going to show a big old red spot right there where there's no insulation where your attic staircase is, right? So you have a heat load right here. There's a heat load right there. And what do you think's doing with the air passing from that heat load? It's going there too, isn't it? So hot air and heat load is going into your return air. Cover it up, put an attic staircase on it. Okay? Attic staircase tent. And seal that thing up and stop that hot air from getting to your staircase. And it makes a world of difference in your home. Yep. Yeah, I'm telling you guys, it makes a world. Where's your thermostat at? Right here. Right by your attic stairs. Right by your return, right? Is that the right place for your thermostat?
No.
Yeah, it is. You just have the leaking attic stairs.
With mine, my house is right underneath it.
Okay.
And I got a big exhaust fan.
Yeah, the exhaust fan, right?
Right underneath it.
Yeah.
I mean,
You can build a ductboard cover over it unless you use your fan all the time, or you can take a piece of metal and screw a piece of metal up with some leakage, with some gaskets on it, and screw the metal up and seal that big opening. Because all it is a big opening to your attic, and it's sucking right into your return air.
I just bought the house. I haven't used it yet.
Yeah, there you go. Insulation in the attic. We talked about the insulation a little bit earlier, R13, R30, right? Guys, if you're looking at the attic and you have what's called a truss roof. You know what a truss roof is? A truss roof looks like this, guys. When you walk in the attic, there's your peak, and then your 2x4s do like this. Okay? Aren't they a pain in the behind to go into? Okay, because you got all these freaking 2x4s hanging, holding everything up, right? Well, that truss roof, the way this thing is designed is you actually don't need a support wall up underneath it because it holds itself up, just like the Great New Orleans Bridge. How can you have that big of a span with nothing holding it up? Because it builds these beams up on top and it holds it up. Structural. So you can actually move the walls out from underneath these truss beams right here, and the walls won't fall. Well, these are 2x4s. Okay? Y'all seen those attics, right? Well, if this is a 2x4, and you're climbing through this attic, guys, and you can see the top of the 2x4s when you're going through there, how much insulation you got in the attic?
13 or less.
R13 or less, right? Because it's 3.5 inches. R13 or less. What's the heat load on your house? How can you improve that? If you see that, you sell insulation. $1 a square foot. Okay? All day long. Alright, we're down to the bottom, airflow. Thermostat. Okay, unlevel or broken. Unlevel is the biggest thing when you have the old analog thermostats where you got a little dial inside of it and you got the mercury bulb falling over. Okay? The digital thermostats don't matter if they're unlevel other than the actual sight of them. Okay? Broken means that it just don't work. Or sometimes they're broken and hanging off the wall, or the cover's broken on them, that kind of stuff. Okay? Your blower motor. I want to know if it's okay loose, bearings, or noisy. Well, if that blower wheel and that blower motor is as it's turning, okay, could have bad bearings in it. Or the wheel, which is the next one, the blower wheel, clean, dirty, or filthy. Well, the blower wheel could say loose on it too. Because a lot of times that loud noise when that blower wheel comes on, it's the blower wheel, not the blower motor making the noise. No, what's happening is the hub of the blower wheel, the actual hub that screws down to the shaft, it's spinning at, let's say, 100 miles an hour, but the wheel itself is spinning at 90 miles an hour. So it's as it's running. That's what you're going to hear. As it's running. Then when you stop, boom, it stops. Okay? If it's the bearings, it's not going to make that loud sound like that all the time. Okay? And every time you turn it on, the hub is spinning faster than the wheel. Okay? Believe me, I've been out there, and I know what that sound is. And I called my old employer up at about midnight one night, and I'm going, that's brand new in the business. Man, I changed the blower motor. I told him it was a bad blower motor, and put a new motor on it, put everything back in. It's still making this loud sound. And I don't know what it is. I mean, it's not the blower motor. He goes, it's the blower wheel. I said, what do you mean it's the blower wheel, man? The blower wheel don't make any noise. Yeah, it does when the hub's loose from it. So now I had to pull the motor out, put the old motor back in, and then get him the blower wheel the next day. Okay? So you got to know what that sound is. Okay? I tell you, you can diagnose the system, and we did a presentation where I went through the entire diagnostics of a home and only had a screwdriver and a pair of pliers, and we went through the entire 9 yards of it with a screwdriver and a pair of pliers, and we used sight, hearing, and smell. And we came up with a ton of different things that I diagnosed that house with without ever putting a gauge or a meter on the system, right? Were you in that class, Ryan?
Nah, you talked about it the first day I was here.
Yeah. We'll do another one because I want to put it on tape as well. All right, so blower cabinet. I want to know if your blower cabinet is dirty, filthy, or clean, right? Check it off there. Now, if it's dirty, you want to give a recommendation to clean the blower wheel and clean the cabinet, right? Vacuum it all out, pull your blower wheel out, clean the actual wheel itself, clean the dirt off of the blower motor, reinstall it. That's going to give you better airflow through the system. If your blower wheel is dirty, is your coil dirty, guys?
Yep.
Probably so. Okay. You got a vertical gas heat system and your blower wheel is dirty. I'm going to give you a little hint. Pull the blower wheel out. Okay? After you pull the blower wheel out and you vacuum the inside of that cabinet, literally get your whole body up inside there, upside down, take your drop light or take your flashlight and shine straight up through the chambers, and you can see the evaporator coil up there, right? Now you can see if the coil's dirty or not. And I'm going to tell you, it's going to be dirty. So now that you cleaned everything there, then you go, ma'am, after I pulled your blower wheel out, I looked up inside there and your coil's dirty too. So I can come back tomorrow and I can clean your evaporator coil. It's $650 to clean your evaporator coil though. So your blower wheel definitely obviously needed to clean. I showed you how dirty it was and I showed you how clean it was when I put it back together. Now that we got that clean, your next thing is your evaporator coil, and it has to be done too because it's filthy dirty and it's going to restrict airflow through the system. Your superheat, your subcooling is going to be off. But I couldn't see it because of the way your system is installed. But now that I pulled that blower wheel out, I was able to get my body in there and actually see it. So that's what needs to be done next. You ready to get that done? Okay. Filter size. Give me the size of your filter, and I want to know if it's clean or dirty. Okay? I want to know what the indoor air quality in the house is, and I want to know if your filtration is okay, fair, or poor. What is good filtration? How about a pleated filter? How about the proper size return air with a pleated filter? How about a PCO? How about a 4-inch deep filter? How about something that's going to clean the air as it runs through? If you can read a newspaper through the filter, it's not a good filter. So those blue fiberglass filters are not good filters. When you see that at a customer's house, tell them they need to replace their filters with the $5, $6 filters. Not the 80-cent filters, okay? Indoor air quality. What do I mean by indoor air quality in a house, guys? Well, you know what? If you just went through this whole thing right here, and you can't figure out what indoor air quality is in the house, whether it's okay, good, fair, or poor, Okay? What's the humidity level in the house? 62%. Do you have a single stage air conditioning system? Yes, I do. Do you have air leaks in the return? Yes, I do. Do you have air leaks in the supply? Yep. Got dirty evaporator coil, dirty condenser systems, low on refrigerant. I got poor indoor air quality. What do I mean by indoor air quality? Humidity level inside the house, temperature inside the house, mold mildew spores, dirty molded supply plenum that we just found. Are you going to tell me you got good indoor air quality when I just took a picture of your plenum and showed you all the mold? Can I put good on there now?
No.
Don't I have to put poor? Well, why are you putting poor on there? You see, you checked off poor. Well, yes, sir. I showed you all the mold and mildew inside your supply plenum. So all your airflow has to go through that dirty blower motor that we just showed you, and a dirty evaporator coil, and a molded supply plenum, and dirty ductwork before it blows in your house. So yes, sir, you do have poor indoor air quality. But I can fix all that for you because I can put a UV light inside your supply plenum and change that supply plenum, clean the evaporator coil, and clean the blower motor, and I can charge your system up properly after all that stuff's done. And I can seal the return air leaks and the supply air leaks and the fix your ductwork. I can do all that stuff for you, sir. I can take care of that stuff for you. Would you like me to go ahead and do it? We do have financing available too.
Yes, sir.
I want to do the whole job for you. Okay? I don't want to be a jackleg technician. I don't want to go in there and I don't want to tell you things that aren't true. And your last thing on this page, guys, is UV lights. Okay, none or blown. Well, I can't tell you your indoor air quality is good either because you don't have any UV lights either. Didn't I just give you an entire story for your entire house? This is how you do a service call. I went over this entire system, this entire home. How many things can we make money on here? And I don't have, with all this stuff, do you really have to lie to anybody? You don't. I mean, you don't have to tell anybody a lie because you can verify everything that you said. You can take pictures of it, upload it in the iPad. You can take pictures of the dirty condenser. You can take pictures of burnt wires on the capacitor, blown capacitor, swollen up capacitor, sweating compressor, filthy dirty filter, return air that's restricted, ductwork that's falling apart. You can take a picture of all this stuff and upload it in your computer, and it goes right into my computer system. Okay? Now when that customer calls back and goes, Ryan was just out here, he gave me a price of $1,900 to fix my system. I think he was just lying to my mama, and that ain't right. And I go, well, he took pictures of all of it. Hang on one second, because I see a bunch of pictures here. Let me look through all. Well, yes, sir, you got a dirty condenser, dirty evaporator coil, dirty blower motor, system's low on refrigerant. You got a superheat that's 35. You got a subcooler, you know. He told you everything that's correct, sir. You know, would you like us to go ahead and fix it? Well, I'm going to get a second opinion. That's no problem. You can get a second opinion, but this is all the truth. You know, if you'd like me to go out there, I can go out there with Ryan and we can verify it again for you so that you see everything that we see. Because I know you're trying to, you know, make sure that your mom's not getting screwed or anything. I understand that. Would you like us to go out there and meet you out there and show you all this stuff that needs to be done? Would you feel more comfortable if I can prove it all to you?
Yeah, come show me.
Okay? I'll prove it to you. I had a guy one time call me up, dude, 9 o'clock at night. This is a true story. 9 o'clock, 9:30 at night, called me up. I was working on one of my rental properties, and he says, this is probably 10 years ago, man. He says, your guy screwed my system up and it don't work. He just put a new compressor in, and it don't work. And he did this, and he did that, and he did this, and blah, 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 and I'm suing you. And I said, I tell you what, I think he put a new condenser fan motor in. That's what he did, okay? And he said, every time I put my fuse in, it blows a fuse. I told him, well, he probably got a bad compressor. Well, your guy caused it because it wasn't doing that before he came out here yesterday. So I happened to call my guy up, and I called that customer back, and I called him up and said, "Tell me what you did out there, because I'm caught completely off guard and don't know what he's talking about, right?" He said, "No, I just put a condenser fan motor in." He says, "So I told the guy he really needs to replace the system, and he told me no, he's fixing to sell the house and he don't want to replace the system. Just go ahead and put a fan motor in." He goes, "Man, the system's like 18 years old, and I kept telling him he needed to replace it, and he didn't want to." I said, "Okay." Call the guy back. I said, "Kevin said that he told you you need to replace the system, but you didn't want to, that you just wanted to replace the fan motor." He goes, "Yeah, he did tell me I need to replace that." I said, "Okay." He goes, "But it was working fine before he came out here." I said, "Well, he had to replace the fan motor, so it wasn't working fine. Your fan motor was bad." "Well, yeah, it was just the fan motor, but he caused something else to go wrong because it keeps blowing a fuse." I said, "I tell you what, here's what I'm going to do." And he's yelling and screaming, okay? So I'm yelling and screaming back at him, okay? And I said, "I tell you what I'll do right now." I said, "I'm going to go over your house right now, and here's the deal we're going to make." I said, "If I can prove to you, and I mean prove to you beyond a shadow of a doubt, that everything that he did is correct, and there's nothing wrong with that fan motor, and if your compressor's shorted out, then you're going to buy a new condenser from me and we'll install it tomorrow." He goes, "If you could prove it to me," I says, only if I can prove it to you." I said, "Okay." So I went over there, and boom, as soon as you put the fuse in, shorts the breaker, right? Trips the breaker. I said, "Okay, now watch. I'm disconnecting the compressor." So I pulled the leads off of the compressor, put them all out to where they can't touch anything. And I said, "Now look, when I put this fuse back in, that compressor doesn't have any voltage to it, right? So that fuse, that breaker should not trip, right?" He goes, "I agree with that." I said, "I'm going to tell you what's going to happen, because I already checked it was grounded, okay?" I said, "When I put the fuse back in, this fan motor is going to run. And if that fan motor runs, that means he did the correct job." "All right." I said, "Okay." So put the fuse back in, fan motor runs. I said, "Okay, the only thing that's not hooked up is that compressor, right?" He goes, "All right." I said, "Now, I'm going to prove to you that it's the compressor now. So I'm going to only hook the compressor up." So I pulled the leads off of the fan motor. Well, hook the compressor back up. I said, "Now watch. When I plug the fuse back in, or the breaker back in," I said, "it's going to blow the breaker right away. So you want to watch?" Click, pow! I said, "Now, we're going to put a new compressor in, a new condenser in for you tomorrow. We'll be here about 8 o'clock, okay?" All right. That's our deal. Okay? That's our deal. We don't lie, we don't cheat, we don't steal. You're going to get compressors, not compressors, you're going to get customers constantly, guys, will try to blame you for everything. So if you don't know what you're doing and you don't know how to explain it to the customer, you're going to look like you don't know what you're doing. You're going to look like that jackleg technician. You're going to look like that you cleaned that condenser really good and you caused the fan motor to go out. Okay? On one of my reviews right now, it says on there, I called the owner and he told me that when they clean the condenser, sometimes the fan motor goes out. If I would have known that it was going to make the fan motor go out, I wouldn't have cleaned the condenser. Okay, so what I told him was, and of course he got it all mixed up, was sometimes when we acid wash the condenser, it changes the temperature of the motor, and it's very possible, depending upon how dirty that condenser was and how long it's been running like it is, fan motor may go out. But it's not because the condenser's clean or we put water on it. It's because the bearings were bad beforehand and now they're running at a different temperature. Okay? And he just wanted to complain, so he goes and puts a bad review on one of the websites. It's just stupid.
Yeah.
You know, I mean, so you got to be able to explain it. And if whoever put the fan motor on would have said that beforehand, or while he was at that job, then he would have called back and just said, "Okay, you told me the fan motor was probably going to go bad. Come on and put a new fan motor in." But since nobody said anything, oh, you caused it.
Right.
Okay? You caused it because you put water on my condenser. Sir, it rains all the time in your system. Yeah, but you shot water up in it. Sir, it's been raining on your condenser for the last 12 years.
Water got
Okay?
there.
If water was going to get in it would have got in it over 12 years. It's a sealed motor. So no, but he was shooting it in horizontal. It don't rain horizontal. Sir, it pours down raining on your system for 12 years.
That thing was back there for Katrina.
Okay? You know, so you got to understand, a customer is going to do everything that they can to not have to pay for whatever's wrong.
Right.
If they were going to blame you any chance they get, because they could have been screwed by somebody else.
That's probably very true.
But I tell you what, as long as you go out to that customer's house, you fill out that invoice like you're supposed to, and understand everything that you tell them is correct, and you're not lying, cheating, and stealing. Okay? You're not stretching the truth either. It's just you're giving an honest opinion. This is what I would do if it was mine.
Right.
Yes, no, you want to do it. Okay, you don't want to, no problem. Here's a recommendation, here's a price whenever you're ready to do it. And we're going to call back on those recommendations as well. Hey, Ryan was just out at your house 2 weeks ago, sir, and he recommended putting a float switch on your drain line, and he also recommended putting a UV light in. Is that something you'd like to get done? Yeah, I do want to get it done. Can you call me back next month? I'll probably have the money next month to do it. No problem. We'll call you back next month. We'll reschedule, call him back next month. He may do it next month. If we never call him back, he'll never get it done. Right? Or, next time you go out there, you look at the documents you seen last time you went out there, you made those recommendations, now you can make the same recommendations. True story, went out to a guy's house. Blew his drain lines out. I wrote honest recommendations. System is installed wrong, drain lines are backing up, all the drain lines need to be replaced, the evaporator coil is rusting out, needs to be replaced, customer needs a new system. Customer does not want to replace the system at this time. Customer signed it. Okay? They paid me for the service fee and they paid me for blowing drain lines. 1 year later, customer calls back. I went back out there and I said, I remember this house. Your evaporator coil's rotted out, your drain pan's rotted out, your drain line's probably clogged again because you got water on your ceiling, I see. And I said, you ready to go ahead and replace the system? And sure enough, they actually had the original invoice on their mantle. And I seen it and went over there and I picked it up and I rewrote everything that I wrote again. Okay? Can you get it unclogged? I'll go blow your drain line, but I'm not going to tell you it's going to stay unclogged. The system needs to be replaced. No, go ahead and do it. Okay. Blew your drain line. Put all the recommendations back down again.
Wow.
About 8, 9 o'clock that night, he called me up. He was mad as all hell. There was his wife there. He's mad as all hell. His ceiling fell in. He says, it's your fault. I'm going to sue you. I said, I said, you want to sue somebody, sue yourself. I said, because I told you a year ago, and him and I are screaming back and forth at each other, okay? And I told him, I says, let me tell you something. I told you exactly what it needed to be done a year ago, and you're too cheap to get it done. I told you needed a new coil. I told you needed a new drain pan. I told you needed new drain lines. And if you wouldn't have been so cheap, then we would have replaced your system a year ago, and your ceiling would be up today. Just like today, I told you it needed to be done again, and you were too cheap to get it done again. So, you want to blame somebody, blame yourself for being so freaking cheap. Okay? So if you wouldn't be so stupid, at this time we were getting, kind of hairy with it. If you wouldn't have been so stupid back then, you wouldn't be so stupid today. I ain't never going to call you again. I'm going to sue you. And I'm like, that's fine. I said, but you know what? All that water on your ceiling and your ceiling falling is 100% your fault, bud. Don't blame anybody else because you're too cheap to get things fixed. There you go. Any questions?
Yes, sir.
Y'all learn something?
I got one question.
Shoot.
The hard pipe,
Okay.
when it's in the attic, would it be better to try to sell them the re-insulation, to re-wrap it, or
Yes.
or soft,
Right.
flexed up.
It would actually be better probably for new rewrapping existing hard pipe, because the hard pipe is the best pipe you got. And if you are going to replace that ductwork, now what if the ductwork is in your way? Because of the attic location and where things are storing things, and they keep piling things on top of the ductwork. Okay, well then now sell them new ductwork, because now we can rerun the new ductwork with a new supply plenum and get the ductwork out of their way. So everyone's different.
I was just curious about that.
If you're selling new ductwork, you can sell R6 value ductwork flex duct or R8 value ductwork flex duct. There is also antibacterial ductwork as well. You can sell flex duct that's antibacterial ductwork. So that's something else that can be done. All right, did I answer y'all's questions and learn a little bit here today on a proposal or an invoice? All right, thank you guys.